is of no use. Almost you're spending around 90 minutes. So in that 90 minutes, I think you should have some insight about what is going on in industry. So in AI powered IOMT, so let us touch some part on Internet of Medical Things and few small devices demo also I have just prepared. So let me show that for you. So you can stop me at any point of time when you need. So I think you already know what is IOMT. So you can just see this definition. So I think you learned about medical devices and in healthcare. So you now know whenever you visit a doctor, um, than checking your vitals. I mean, vitals means checking the blood pressure, checking the heart rate, that is blood pressure. All those things are called as vitals in medical technology. So instead of that, that is even done by some, I mean to say, sisters. And then the doctor just looks into the reports. He just if you tell some reason, he's not going to think more, but he gives you some of the medical tests to be attended, and then only he is talking. Actually, nowadays, I think doctors are more relied on the machines nowadays. Like how we are actually more well versed to the devices, our own devices. So like that, so they are also complete examination or complete prescription they are not able to do without using the devices. So when you talk about many healthcare, many corporate hospitals, especially, they have very good sophisticated technological products from German. All are imported. Not a single machine is being made in India. All are Korean based and then German based machines they're actually using. So medical devices. So there are two things which are to be remembered. One is you have many devices which they are using. That is, one is the data in that, the most crucial part, and the second is how they are communicated. So as engineers and as researchers, we already know in the communication there are many technologies. For short communication, you'll use some communication network, and for long communication, you'll use some of the um, device, some of the network. And nowadays, it's even not that people are going for edge devices, edge computing. So when you bring all these, so can you tell me how many or short range communications networks what you're using currently? Any one of you? Any one of you? You can see I have given one example as Wi-Fi. Yes, Bluetooth, Zigbee. Yeah, those are short communications, right? What type of network it is used? It is using,
Sigfox. Wireless communication.
yeah, wireless communication. And coming, if you go for long distance communications, so in that case, people do use cloud, right?
Yes, yes.
Yeah. So either go and connect to some wide area network or go and use any one of the cloud technology. So that is actually being done by any type of device. It can need not be the medical device, but now when they have started this transition from the actual world to the medic IoT world, so people have initially they have used all this short and long range communication starting from LAN to MAN and then WAN network. But when they started using IoT, not medical things, I'm saying IoT, Internet of Things, they used the cloud. Okay. And when they use cloud, initially they have used some free cloud devices and they have exported lot of data into that. And then again, after that, they got some privacy concerns and then some data security concerns. Then they moved to their own server. So their own server, in the sense they have their own application where they don't want to present all these data to outside world. So there actually this authentication, this storing it in the server, it became very costly for them. So that is the reason why this research of medical research is very costly, because data is not freely available. What they'll do is you may have synthetic data which is available in the in your where freely available websites, but then it is not more. It's all synthetic. It's not realistic data, real-time data. So that's why they are paying lot of money to these cloud like Azure and then AWS softwares to store their data. And then again, they had some connection creation, creating these endpoints and then deployment. So that is again a big side that is that actually the software guys are actually doing for them. So the practice of there are few other names actually given for this IOMT. One is telemedicine. So I think this FDP itself is using this telemedicine as a term, and more oftenly, even Internet of Medical Things is called as healthcare IoT. Actually, initially they used to call in that way. So there are multiple names, but on the whole, two things you should remember. One is they're using the IoT technology, communication, and another one is the data. So from many, many devices, these people are sending data. So right from the sensors, right from the I think sensors are being installed in the watches, and then from completely from the devices which were available in the hospitals. So those devices are also sending data. So that is the reason why AI has come into picture. And these are some of the examples what I was actually mentioning in connected 5G and IoT. So this was again initially 4G was not used uh, when it came to healthcare. It very less applications you had in the COVID time, but after the 5G has come, because of its reduced spectrum, reduced usage, more space in the spectrum. So people started using this latest technology with higher gigs of speed. So in that, so this is what these are few of the applications. I think you already know them. Connected ambulances. So ambulances, if you see, earlier you don't have any control system or you don't have any complete setup in the ambulances. But I think here we don't see much. But if you go to any other countries, you'll see a lot of big machinery is actually present inside the ambulances. So which are connected to the network. So 5G enable paramedics. So actually those staff are actually called as paramedics, right? So there is a course also for them. So paramedics, they would quickly monitor their records like blood pressure and their vitals. They'll check their vitals and then they will transmit all this data to the doctors, connected hospitals. Actually, before the patient arrives to the hospital, they are actually maintaining all the preliminary actions that are to be taken. And next one is remote surgery. So even the surgeries, like you have most senior doctors are to be consulted, then in that case, they are actually using um, normal surgeons you have here and they wanted to have some consultation. So it's not robo, but consultation is being done through remote. Robots are also there, but much of them is remote surgery. And then IoT sensor. So this is actually this is the place where lot of devices are being planned, much of business for these people, and AI has come in that way only. See, 5G AI and a network of sensors connected to the cloud, and also edge analytics. So this is actually being the way it started, and now also you have a lot of sensor data which is being monitored, and researchers are using them in their analytics to develop some powerful applications using AI. So these are very few examples I have shown here. So coming to, let me go straight away to how this Internet of Medical thing is working. I think you know this all layers, but let me show all the layers what it had. So some of them just know the application layer, because in the application layer people have many medical sets which are actually available in the internet. They browse it, they download it, but you just remember they are not real time data, they are all synthetic data. One sample of data will be available, and they continuously generate it by some pseudo random algorithm, and then they generate that synthetic data, and then they are actually using it for various research purposes. So here in the application layer, so that is what the research people, or even we used to do research on this area only. So even in industry we do research on this only. Like you have some real time data, and then you apply some AI technologies, and then you develop a model. But there is a big thing that happens after it. So I think many of you have worked on AI, and you have been developing few models using machine learning, right? So can you tell me any few of the models that you have used? Anyone is doing their PhD in AI data science? Can speak. Anyone? How many participants are there today? 2 pages, 25 people. Yeah, any one of you are doing PhD in data science? No one? You can chat him, you can type a message if you're not able to speak. I see many doctors. So any one of you are working in data science? No? Okay. Yeah. So generally, when initial days, like when we started even research on data science, so we used to think that lot of time is spent on developing the models. But after going into industry, then we actually observed lot of time is spent on the analytics, data analytics. So almost we spend 5 months on data, pre-processing the data and understanding the data, because I work for the drilling side, and I have the clients from Northeast and Houston. So those clients have given us data 2 years back, initial days. So almost 6 months we took time to understand the data. Like, see, for a model, you always know that for a model you need very less data for preparation of the model. But the data availability will be 1 year data will be thrown, and on every day you have 900 to 800 entities. Entities, I mean to say, like in each entity is like a group, is like an ID. So each ID will have multiple features. I actually work for a few feature data. So say for example, I had some 10 features. So our initial project was on wells, artificial lift wells, mechanical wells, and also electrical submersible pump wells. So we used to have few pressure and temperature features, and also some features on the motor. So those features you will take for 900 wells per day. So just think about what is the size of the data to process 1 year data and then understand and pick up the very crucial data to prepare a model. So that takes huge lot of amount of time to understand first, and then analyze it, and then pick up the wells which were healthy and which were unhealthy. So like that, if you apply the same thing to the medical technology, I think you heard about few clustering mechanisms, and you heard about unsupervised machine learning techniques. So initially we apply those unsupervised machine learning techniques to understand and separate out the healthy and unhealthy. So the same thing, even in medical data, you'll separate it out first into two groups. One is a healthy patient data and another one is a unhealthy patient data. So you separate it out, label it, and what happens is there is another particular thing which is very, very important. Like, there can be symptoms for a particular patient who's healthy, but there is a period where he has unhealthy signatures. I mean to say the pattern, unhealthy patterns. For example, if I take any disease instance, so in that case, what you will see is a patient is categorized into healthy and non unhealthy, completely unhealthy. Unhealthy, he is having unhealthy vitals as well as unhealthy signatures in the complete record, say 1 year data, last 3 months. So that last 3 months, what I actually am mean to say, those last 3 months ought to be labeled as unhealthy for him, but rest of the portion is healthy. So like that, the labeling plays a very, very important thing. The first thing is grouping them, clustering them, and the second one is you have to label it correctly. Then you have to understand the signatures. So that is again one more important thing. Signatures, I mean to say the symptoms. So here symptoms, you see again critical symptoms. A sudden symptoms is, for example, a patient having a disease, suddenly it rises and all his vitals are actually going to be high. So in that case, there will be anomalous observations in all the features, what you are actually capturing there. So, and some of the patients will have a constant increase in the symptom. So those ought to be separated out. So that's why you'll apply it to categorization. You'll categorize it into low, high, and then moderate, and then you try to give it to the training. So that is all completely taken as pre-processing step. But there is another thing called as see, when you have lot of data, then it is very easy to make. But in some applications, you will have very less data. Say, for example, we have worked on one particular application where those Korean children have, there are many children which who are psychiatrically affected. Like by birth, I didn't remember the disease name, but that disease is they are slightly hyper, and they forget frequently. So such type of disease, when you analyze it, some of them have spontaneous actions and some of them will have slow reactions. So in that case, you have to categorize them and then label it appropriately. So that is where the pre-processing plays a major concern when you prepare a model. So that is the application layer point of view. But when you start with the perception layer, so in the perception layer, you have the data coming from various data sources and also from various sensors. So the data is being collected from various sensors. And I have just given one example here. So where you have this is actually a JSON file. Data is actually stored in JSON. If any one of you know about .json format, I like Excel and like CSV, you have this is one type of format. So here, um, some of the vitals are actually being stored while the activity is walking. Here you have the heart rate, respiratory rate, and heart rate variability, body temperature, blood pressure. In that again, diastolic and systolic 23, 34. So like that, these are the vitals which were given from various sensors. And from there, it is actually given to the perception layer. So perception layer is actually called as a data collection layer, because in some case, actually now, if you see very good health monitoring research activities, they have their own SCADA units. So I mean to say SCADA in the sense, so in the SCADA, you have various sensors for each and every type of disease. So a person having multiple sensors which are being on his body, and all those sensors are reporting, and it is stored as single entity. So like that, you are actually observing many patients' data, and then it is actually being persisted here. Once it is done, the next one, what I told was it is gateway. That is a network. So here, when you get the data, the other challenge is to which network it is being connected to. See, is it um, direct communication, or you want to send images? See, sometimes it's not only the data, you have to send images. So that's why all these what do I call as electronic medical records, EMRs, they have become popular. So many of the companies, software as well as software companies, are actually working for them. So they have their electronic medical maintenance, because a patient, when he enters into the hospital, so and you are a patient from last 2 3 years, so you have the complete record in their software. So those softwares are actually what I'm trying to say, EMS. So those softwares have an option. Initially, you don't have an option to upload the records, but now various facilities were actually being available from last 10 years itself. So you have everything which is being uploaded there, and the same using authentication, login and password, the doctor is actually going to log in there, and then he's going to access your records. So that is the reason it became, nowadays it is very easy with respect to, because of the software. Otherwise, earlier we used to use this communications, either go for um, communicate long range or short range communication, and then transmit the data. And coming to the data storage, so this is again a very big challenge in, especially in the industries. So you have lot of data. I said an example, right? 1 year patient, every day you have thousands of patients, and per day, just think about the volume of data. And per patient, you just think about how many tests are actually being conducted. Minimum 10. So those minimum 10 into 900, 9,000 records per day, and just think about 1 year, so 365 days into these 900, 9,000. So these this
వీళ్ళంతా మేడం సగం చేయటము ఈఆర్పి పోవటం సగం చేయటం ఈఆర్పి పోవటం అప్లోడ్
can you mute yourself? Who's that? So that is one of the biggest concern actually. So in that case, how it is actually being accessed? So any one of you, can you tell me what type of storages were being used in the recent times? How do you store the data? In addition to what I have mentioned here, like cloud and then computing. Any one of you? Any storage? What type of storages are actually used um, when you want to develop some models? When you want to, I told you one application, right? I have lot of data now, around 9,000 records per day. Where do you store it? Or they are going to throw your records after a year? No, right? In corporate hospitals, especially, they spend crores of rupees for them for the storage. So, in industry and even in corporate hospitals, how are they storing is they use databases. I think you heard about it. So databases like, I think, MongoDB and then SQL database. So people use these databases. Initially, we also used to use SQL, then we switched on to Mongo. So where the type of storage, so because they're converted into tables, each and every record need not be stored in each and every table. All are linked tables. Say, for example, you have a name record as a single table, and you have a disease diagnosis as another table, and then you have the reports as another table. But finally, using the index of each table, all those are linked. So in that way, any database is worked in that way. Okay, but when you talk about the still huge data, okay, and in that case, see what happens is, when I use an SQL or a MongoDB, it is on my PC. So in that case, if it is in the PC, what happens is it starts consuming lot of memory, and the processor becomes slower in that particular only single machine. If I use only a single machine, but when you want to export it, then also it takes a lot of time. So people started using cloud, but cloud asks for paid services. So people are spending a lot of amount to store all this into the cloud. So in the cloud, so when I mean to say cloud, you may have Azure storage and you may have AWS only for storage. And this has actually cloud platforms which there what it is actually doing is it is capturing all the data, and even the analysis can be also done. If you see the Azure has its own AI, which can develop few models on the data whatever you stored it in the cloud, but based on the pay and use terminology actually. And coming to fog and edge computing, so anyone of you know about this edge computing or fog computing? Heard about it? Anyone? What is fog computing or what is edge computing? No idea? All these are actually parallel processing techniques, or even I can call it as distributed computing technologies. These are. So these, even I can even name few of them, like grid computing is also there. So grid computing and fog computing, edge computing. So when you talk about fog computing, so unlike cloud, in the fog computing, it also has few layers actually. So it has some hierarchy of layers between these hardware components and the cloud server. So that means you have a server and you have various layers in between, and then they're actually um, com connected. So in between you have few connectors, and what it does is it when you have these layers, the amount of data storage, the data stored across this cloud. See, when you use cloud, what you have to do is complete data is to be stored in a single location. But whereas if it is computing technology like fog computing, it was distributed across multiple layers. So that is the reason it was able to store more data and less cost actually. With even network bandwidth, or even if the network bandwidth is low, the response time is very high using this distributed computing technologies like fog. And coming to edge computing also, so even in edge computing, I think you heard about edge devices. Edge devices are different and edge computing is actually different. I'm talking about it with respect to the distributed computing technologies. So instead of again placing the data in the complete in the cloud, it will maintain a network edge near the device. Like for example, it has you are monitoring, you're taking the data from an instrument. So at the edge of that particular device itself, you have the storage. So that is actually the edge level. So in the main advantage of edge level is this the lag, the latency is actually less. It will minimize the latency, so that otherwise you have to stream lot of data, read and then write the data. So in the case of real time IO medical IOMT devices. So that is about the storage. So and if you see, people have these data storages in other countries. Say for example, even our clients are in northeast, and most of them were in northeast and even in Arab countries, but whereas our storage servers are in Singapore. So all those servers, so how are we actually transferring it? Through virtual private network. So through network, instead of using cloud, we have the servers in a remote location, and you are every day transferring the complete, not transferring, you're accessing the data from the server. Okay. So that is the data storage, which plays a huge role in the IOMT. And coming to the how, yeah, whatever I just told you now in the cloud computing. So what are these different types of transmission data? Even through Wi-Fi, through 5G, through VR and AR technology. So there was an example also, I think XR Health. You can even type that XR Health. If you browse it, you'll see they have their own devices actually. They have a telehealth virtual reality system. So XR Health is that they have actually designed some VR technology, those spectacles and a headset, so that they can reduce the stress of the patients. Actually, this was started with the COVID time, where people were quarantined for weeks together. So for them, they had to reduce the stress for them. So they have actually devised this telehealth VR system. So so that both they can make the interaction physically, remotely, and then they can make the patients to do some cognitive exercises, yoga, and also to engage the people. So they have actually they have invented that invention actually. And smart medical devices, I think these are very high now. So you have people are using smart watches, and it will give you every day, it is actually going to give you all the vitals. And you have what I told you, wearable devices, transportation also. And the smart hospitals are continuously transmitting the data, maintaining the data in the cloud, and even remote diagnosis. So this is what actually I was talking about, EMR, electronic medical records, webcam connect. So through webcam also, they have the complete medical diagnosis is actually being taken. So this is how it is actually working. And let me show you another one also. So this is with respect to the software end. So this is when I talk about, this is about the which layer it is. This is the first layer, data sources perception layer. People do talk about this, but when you talk about the network layer and the analytics. So these were three what I was actually talking about. In the cloud layer, people do push lot of data, and then they AI researchers or the data science people, they can use analytics to really create few models. But whereas in the fog layer, what I told you, the server or the type of the memory data storage databases, where they're bothered about storage of data and also communicating um, through fog computing, through again distributed computing. So, and coming to edge layer, so in the edge layer, the you have already some uh, edge devices, so which were actually connected to the SCADA. So directly you can receive those SMS and messages through our apps in the mobile. So even it was even earlier it was just developed only for Android, but now it was even people are developing it even for iOS. We have edge apps which every day we can um, monitor the patient's daily profile or anything. So based on the application. So in the coming to the application, I'm into show about the persistence. So you have all the sensors which are being continuously giving the data to it. And yeah, let me show you one small presentation, one small simple telemedicine application. So this was in India, a demonstration of how telemedicine can help patients. This is actually an eye examination in the healthcare industry. So let me show you that quickly. I think I should share it again for the video. content with can you see my screen? Can you can you listen to the audio of also audio of this? So you can see first thing is he's taking the vitals and they have their own software which is actually being shown here. And those vitals were actually transmitted to the doctor actually. So I think you have seen this particular video on telemedicine. So what he was actually doing is he is sending the complete examination and eye snapshots. Those were actually being stored in the portal. So the another one important thing that came into my mind was prescriptive analytics. So people are now um, not moving into creating to the models because you already have auto ML. So the moment you give data, the software itself, even in I think in libraries, you have an auto ML facility. So auto ML packages are available. So using auto ML, you can automatically uh, ask the model to auto enable model feature so that it will automatically create 10 or 15 models for you based on the data set. Say, for example, you want to do it for a classification, binary classification or a multi-class classification. It is actually going to use one of the what is that? One of the logistic regression kind, and one of the decision tree based method, and another one is based on the deep learning, and another one based on the distance based. So like that, based on different techniques like um, soft mechanisms. So all using all those different techniques, it is automatically generating models. Actually, we have used data robot, and so the data robot will when you do the pre-processing correctly, and if you give the data, it will ask you to generate. It will ask you an option like, do you want to go for a non-time series model or a time series models? And then it automatically generates you hundreds of models. And even this auto feature discovery is available. So you can generate few derived features out of it. So like I think you heard about rolling features. So generally when you have 10 features, so out of 10 features, direct 10 features may not be useful every time. What happens is, I told you, like for example, a patient having unhealthy observations in the last 1 month. So the 30 days of entities were labeled as unhealthy. I'm talking about the data perspective. So when you label it as unhealthy, in that unhealthy of 30 days records, and each day what happens is when you observe a particular the BP of that particular person, every day there is a slow increase. So you observe a variance and a standard deviation. So how much it is variating from the mean with the previous records. I mean to say, generally what we do cumulative mean, and then you compare it with the previous data. But now when you, instead of doing it manually, you have a rolling mean, rolling standard deviation, rolling sum, rolling difference, of last 15 days, last 7 days, last 30 days. So those windows can be automatically being given, and it can generate multiple rolling features. So like that, you have already few existing scikit libraries which are already developed for you, which will automatically generate all these features, and then it will create you top 10 models, and out of which you can select one model based on the error measure. So people do use AUC or anyone. I think RMSE, root mean square value, also people use. We have used AUC. So that area under curve, I mean to say. So use any one of the error curve, error mechanism, and then based on your criteria, based on your application, you will choose the best model. So now creating the model is actually not an engineering job. So it is already being done by the softwares. But what is being important is the prescriptive analytics side. So people are moving towards um, prescription, because a doctor takes his vitals and he measures all his test reports, and then he has to take some action, right? So that action, how he's going to take that, is again, those all actions were actually again being given to the model. So that's what we have actually done. The doctor's prescriptions were um, taken for learning. So that was used to create a model, and based on the type of diagnosis made previously, so the prescription is being mentioned. So that is actually playing a vital role in the today's industry, and also on automation. Because see, without automation, what happens is the experts have to spend a lot of time in analyzing the data of the patients and then taking a decision. So instead, if you have an automation software, if you have an automation code, it will automatically do whatever it has to do prior to the prior to the doctor's advice. So their AI is actually being used in that area nowadays currently. So we are also using the same thing from last 3 months. So let me show you the another perspective of it. There is, I want to show you, if people are actually interested to start working on into IO um, IOMT, I have a small example which is available in GitHub. Let me show you that also. So please, if you are not being attentive till this time, it can be known from the slides, but please uh, uh, pay some attention in the last 20-30 minutes, so that I'll show you some of the examples. So here, IOMT Fire, I call it as Fire Connector for Azure. So this is actually a software. It's actually an open source software which was developed by an MIT researchers. So this is an open source Microsoft healthcare project. Let me, this is actually that project. So here, what it is actually doing is um, it is a facility where you can connect, and then you can ingest data from various medical devices. For example, you have few medical sensors if you have some sensors which are being attached to human bodies, so that data you can give it to this particular server, and then you can transmit it into the Azure cloud. And also a dashboard is already being created there, so you can directly use it. So you can try that. Then you'll understand many points how telemedicine softwares are actually working. The goal of this platform, whatever they have developed, is to enable developers to, whatever I told you, rapidly deploy a service for ingesting high frequency IO medical data and landing the data in the server. So I wanted to tell, before going into the video, I just wanted to tell you a few points. See, generally in how the process works in industry, I just want to tell you. So the client wants some application, so he gives some real-time data, but some of them, they don't want to give the data also. They ask people to come to that particular location and then develop the model and then go back to their place and then monitor remotely. So because the people don't agree to even send their data through cloud. So that is also there. But many of them, what our client was, they have actually they're accessing the cloud, so they have used Azure platform, so they have uploaded all the data into the Azure storage. So that is one phase. The next phase is they'll ask us to deploy that particular model in their production environment, and they wanted to run it in the live. What does it mean? You have developed a model and you have installed it in, you have installed, I can say. You have installed it in their machine. It is implemented and it is running. Now, see, how did you develop the model? You have developed it using last year training data. Now, you want to test it with the current blind test data. I mean to say current blind test in the sense, um, I think you remember the data was divided into training and then testing and then holdout data. So that partition you already made and you tested it and you have developed the model. But when you work it, when you make that particular model work in the real-time environment, that means the next year. Say you have developed the model till using the data till July 24. But now the model is being running live from August 1st onwards, August 1st, 2024. So they will take another 3 months to make this model run live, but provided you should monitor it remotely. So we monitor it remotely, and then we see how it is actually diagnosing the events. So once the diagnosis is done, they have their own experts who can monitor it through the application. So we have our own application. So in the application itself, they can monitor it and they can diagnose. They can zoom in, zoom out, long-term window, short-term window, any 2 days, 1 day level also they can go, because every day I'm talking about say 900 entities, but each entity will have 30-minute sample per day. Just imagine 24 hours, 48 observations you will have. So 48 observations per day. So 48 observations per day and then 900 entities. So those many records will be there. It's not so easy. So what they wanted to do, they wanted to see only those diagnosed events. So they will see that. So 6 months they have observed live, and they have showed us every month we'll have a review. So in that 1 month review, they will show us that these are the diagnosed ones. And then we developed some power analytics software through Power BI. So in Power BI, we are actually going to show them that some statistics about what is it, why it is diagnosed, what feature has made it to be diagnosed. So what is the feature trend? So those things we can show to the experts, because they know this, right? So as data scientists, we don't know what is that diagnosis for. We just know based on the data analysis. So that will be done. And now they will, if suppose they are satisfied, they'll ask us to deploy it in their server. So when we have implemented in there, it was running live. They wanted to deploy. I mean to say, deployment in the sense, we will create an image of this particular model. Okay, it's not in the cloud. Sometimes people do ask for cloud and some of them don't want to use the cloud. So then we use a Docker. So using the Docker, we create the image of it and then we transport it to them. And then they, again, they download it and then through their Docker, they will install it and then make it live. So that is actually, I call it as endpoint. So that's what is the process. So now after 6 months, if they agree, then again they give some other case study. So this is the complete process for in any live environment. So let me now show you um, a an application, the same type what I was actually telling you. Hope you can see this. See, let me quickly show you where actually I was referring to. So you can even type it in your laptops. Uh, I'll just say it is IO empty FHIR file GitHub. So you can just open it and hover around each and every page and you can just go through that. See, let me show you what I'm actually, what that particular video is talking about. See, what is the architecture and what they're talking about. Let me just show you this. Yeah, yes. So this is the type of data which is actually stored in JSON format. And yeah, what is he actually meaning? See, these are the different types of inputs where the data is being streamed. You have watches, hospitals are sharing the data, some statistics from storage, ambulance, and from vitals. All this data is actually coming into IOMT Fire connector for Azure. So this is actually acting as a connector. That means just an input. It is actually taking the input and which is in the Azure. Because I'm not supposed to open my container, otherwise I could have shown. But you can please go, just remember this particular. I will even type it in the chat for your reference. You can just open it and then if you have any questions, you can just ask me on that also. So if I show you this, so what is actually being done here? Um, people, you know what is meant by normalization of data? Because each and every feature of this particular data, when I'm talking about a data set, you have multiple features, and those features will have a different type of different magnitude. So if you want to normalize, why are we going to normalize? Because I want to put it everything in the single scale. So if you want to scale it, I'm going to do normalization. Then you're going to group it. I mean to say, I told you, right? All cannot be grouped into the same category. So you may have multiple categories. So you have to group that particular data. So you can see based on the measurement type, based on the configured time period, you may have different type of group. Then transform. So transforming in the sense you have to create the observations actually. So you will transform it into a different type of format actually. So you can even call it as formatting also. Say for example, the in the file as a server, it accepts only JSON files. So you have to transform it into JSON. So the data is transformed into JSON format and then you persist it, persisting into the server. So this is what she's actually talking about. So let me play the video. I think you can hear her voice also, right? If not, you can listen to it later also. They are actually they have developed an open source healthcare project that researchers can freely use it, and they can contribute some data also to their software. So that was actually their intention. So let me play again. See, you heard it, right? So you have lot of data which is available in the medical records, but the problem is it's not in the correct place. And so what happens is only few vitals, few very good records, they will spend some money in Azure and then they are going to store it in Azure because Azure has a standard authentication security which is being because it's a paid one. So that is what actually she's talking about. Health information. So let me talk about this also. So here, this is the connector what I have just shown, and the next one is the API. So APIs are actually interfaces. So interfaces between the device and your software. So Azure API for Fire. So you wanted to store the data into the Fire. So for that, you should create some endpoints. I mean to say endpoint in the sense, um, see, if you have a model, so that particular model, when I'm making it as a image, I mean to say image is a Docker container image. So that image, I have put it into Azure. Now, the other person, the client somewhere, a remote guy, he will he will access the Azure. He will access the Azure login. He will access this particular endpoint. But how will he open that? He will use Postman. So this is one type of endpoint software. So Postman, you can you can type that. It's like a hyperlink only. So in the Postman, he will open the link in the Postman, and then you'll get the output. Output is what? The prescription or whatever you have stored it in the output type of the model. So that is the Postman actually. So let me resume it back. Yeah. Yeah. See, this is actually what I'm talking about. This is the endpoint. So Fire Meta endpoint, because she has created a demo server, and now Endpoint is the connection actually. So when you type the endpoint, it will have the behavior of your model. See, this is the same page what I have actually shown you. IOMT fire. Now you understood, right? So you are reading the data from the devices to the Azure, and then to a connector, through a connector that is endpoint, you're pushing it into the server. So that is what is actually happening here. Yeah, this is the authentication key. See, this is an IoT central application what they have created from the resource groups. So like this, actually, we create many of the resource groups. So there will be simple standard Azure documentation to create this. We also have created the same type. And then here you can see resource group. And then you have a template. So you'll have multiple templates which we will create it. So using that template, for example, it can be a medical record or a fault prediction. We are actually doing failure prediction, so failure prediction template, or it can be an imputation template. So templates will be created by us only actually. Then we'll use it here. Continuous patient monitoring. See how it was very powerful. They have already that template is actually showing us a dashboard. And see where that particular dashboard has a vitals. You can use vitals or you can change the patient. So many pages were actually being created in this dashboard. Yeah, so this is what actually I have also highlighted. People, whatever is available in the websites, it's not a real-time data. It's a synthetic data. So they will synthesize it, replicate it, create duplicate data, and then they are going to send it. See, this is what actually I have put in the slide also. You can see heart rate, respiratory rate. So this is one. See, for example, smart knee brace telemetry, acceleration, range of motion, knee bend. So, but they are actually using JSON, but we have actually used both formats, CSV as well as JSON. So any format, it's up to us actually. See, this is the template what we are actually creating. See, they are using only the heart rate here, and here only at the rate body dot respiratory rate. Yeah, this was actually used. Data, and then only save. So you're exporting it actually. So you can see the overall flow now. So from the IOMT device, you are moving it, you are transforming it into a format through the connector, and then you are pushing it into the, you're exporting that particular data. Now you'll access it through Postman. So you can see them. Let me just give you a small description on what is a postman actually. So the postman accept has actually three type of commands which it will accept. So you can even type what is a postman if you want to just Google it. So this is actually an API software. So here you have a get and then a push. So what is actually I'm doing is get in the sense if I click this particular link, I am accessing the endpoint. So in that endpoint, you are actually, see here you'll have the parameters, headers, body, tests, and then settings. So generally we'll have authorization key for the key, and you can see it is using one of the port, actually our local port. And then what parameters it has, and the headers also, headers ought to be neatly constructed. And then um, if you type this link, you will should have the behavior of that particular endpoint. So I'll continue this. See, this is the till observation, it is the endpoint, and this is the code actually. Respiratory data. So this looks actually a complex output, but generally what you can share is simple only heart rate and only um, respiratory rate, anything you can just import it, but all these are proprietary softwares. So that is the reason why I'm not able to log in it in my personal laptop. But otherwise, the industry standards will have all these proprietary things. But Postman, I think you can play around it. You have some freely being accessed through Microsoft account also, so you can access that. So that's what actually I was trying to show you on this respective. And yeah, these are the examples what uh, I'm actually thinking I will show you. And let me just show you that page also for you. Yeah, GitHub repository. They have even updated it recently. So this was actually being done by the MIT researchers. So let me show you the images, templates, whatnot, even process flow, everything they have actually, what I showed you, those were actually available in this images, normalization example and all. So whatever, if you want to give some data, play around it, you can go through this particular website and then you can use it actually. So let me show you something in the tree. Deploy templates. Container app single as you deploy.json. Yeah. So these are few of the templates what they have actually created. So you can hover around all of these and then you'll understand if you want to use it actually. So this is one example. And let me um, show you even the challenges, especially in medical. So the main challenge is data. So data only in data science or in analytics. You have lot of data and not all data is to be shared. Say, for example, you want to develop some code for your application and you try to use ChatGPT, you paste it through all your variables. Don't do that if there is security concern. Yeah, for research, it's fine. We can go through it. But in the industry, we don't type the same variables as in, we just say ID1, ID2 like that, and then we get the data from the GPTs. And scalability upgrade, yeah, this is again another challenge. Upgrading to one capacity to another capacity. That is again another challenge. So definitely it will involve some cost. And one more thing is environmental impact. Actually, what we do is the entities which were actually having environmental impact, we filter them out because it will have a different behavior. And we don't expect it that the model will try to be biased based on this environmental concern. So we filter it at the input itself. So coming to data management, yeah, these two are actually data management and also interoperability. So this is again another important one to be dealt with, and power consumption. So yeah, of course. So based on the data consumption, based on the challenges what we have in storage, everything. So definitely you're going to consume more time, more power uh, of the people. Yeah. So I'm done. And if you have any doubts, so you can ask me.
Madam, it is MuleSoft, ma'am.
Uh, Come again, I didn't understand.
It is software is MuleSoft.
No, it's not any software.
I mean, you written the code in JSON format. I think. What is the platform to build these programs?
Okay, it is Visual Basic.
Okay, okay.
Yeah, some of them use C sharp, some of them use Python. We used actually Python, but the output format is JSON.
Okay, in
Because,
MuleSoft also we can do this such type of things. I think.
okay,
Am I right?
yeah. What is it actually? I never heard it. What, can you spell it
MuleSoft.
out? MULE?
MELESOFT.
Oh, okay. MuleSoft. Okay. Okay, this is API. Yeah, yeah. This is also an API software. Yes. People do use Visual Studio, even C++ also. Our application software guys, they use C++ actually. Some of them use Visual Studio. In Visual Studio, they do it in C++ also, C Sharp also. So main thing is they have to develop the APIs. They have to write codes to develop the APIs so that it will be interfaced to the software. Hope I answered your question.
Yeah, yes, ma'am.
Okay.
Is there any questions? I think no more questions, ma'am. Thank you, Sweta, ma'am. Thank you for your
Yeah.
hello.
Thanks, Anil. Yeah,
Yeah, ma'am.
thanks,
Yeah,
Anil,
ma'am.
for giving me this opportunity.
Yeah, madam. Thank you for agreeing this. Even though your today is your week off, even though you are agreeing.
Fine, fine.
Yeah.
Yeah.
Thank you.
Thank you. Bye.
Their participant next session is taking by the Dr. Joseph Benjamin Garu, head of the radiology department, MNGAO RCC Hospital, that is our government Koti Hospital, Hyderabad. His topic is smart sensors for monitoring cancer related quality of life. So the session will start by 3:30. Sir, Joseph Benjamin, sir. Good afternoon.
Can you see me, sir? Sir, can you hear me?
Yeah, sir.
Thank you.
Sir, shall we start the session, sir?
Sir, yes, sir, I'm ready, sir.
So, dear participants, now this session is taken by the Dr. Joseph Benjamin Garu. Before going to the session, just I want to give you a small introduction about of our today's speaker. So, Dr. Joseph Benjamin Gandhi completed MBBS in the year of 1987 from CMC Vellore and MD in radiotherapy from Christian Medical College, so Ludhiana, in the year of 1996. He was clinical attaché January 1992 to December 1992 at Department of Medicine and Cardiology, South Shield District Hospital, South Tyneside, UK. He has worked as senior resident CMC Ludhiana and also at NIMS Hyderabad. He has served as assistant professor at Sri Venkateswara Medical College Tirupati and at MNGIO RCC Hyderabad. Served in various capacities as assistant professor, associate professor, professor and HOD. He received Dr. Frank Neil Fellowship, Association of Radiation Oncologists of India, to receive advanced training in the field of radiation oncology at Tata Memorial Hospital, Mumbai, India in 1996, and received Rashtriya Ratan Award by International Study Circle, New Delhi at the seminar on role of medical professionals towards society on 22nd May 2006, New Delhi. He is life member Association of Radiation Oncologists of India, Board of Studies member of SVIMS, and Ethical Committee member of ICAR IIMR. He has guided several MD students and is examiner for MD students in various universities and has published several papers in the international journals and conferences. So with this introduction, I am cordially inviting Dr. Joseph Benjamin Garu. Please take the session, sir.
Thank you, Anil. Thanks for this nice introduction of yours. I don't deserve all this. And I'm really privileged for you to be given an honor to be one of your speakers. And I would love to get into this topic and speak on this topic.
Yes, sir. Thank
And
you, sir.
the
First of all,
topic
I
that
am
is,
apologized for the pressurizing you to take this session, sir. I
yes,
am
sir.
apologized for
Yes.
my pressure, sir.
Sir, I'm really thankful to you, sir. I mean, I don't deserve all those good words that you spoke about me, but I thank you very much for
Thank you, sir.
giving me this opportunity. I tried my best
Thank you, sir.
to present myself well. Hopefully, I promise that I'll do my best as possible.
Thank you, sir.
So
Thanks.
the topic for today, FDP, is smart sensor for monitoring cancer-related quality of life. Again, I read smart sensors for monitoring cancer-related quality of life. I want to deal this topic under the following headings. One is introduction to the topic, cancer basics, the biomarkers, the smart sensor technologies, detection mechanism, application in oncology, challenges and future and conclusion. Now, coming to the introduction, cancer is a major health concern. It is the second leading cause of death globally and after cardiovascular disease, and its incidence increases with age. Number one killing disease in the world is cardiovascular. The second is cancer. So cancer is one of the deadliest disease globally, requiring early detection for survival. Early detection for survival. Early detection improves treatment response, survival rates, and reduces cost and mortality. The traditional methods often require multiple steps and can take hours or even days to produce results. The traditional methods like biopsy, imaging are costly and invasive and inefficient for early detection of cancer. The technological advancements are crucial. Combining genomics, proteomics, data science with computational biology and bioelectronics is essential for developing more accurate and specific cancer diagnosis. Now we'll come to what is cancer. Now, the way you can explain this, cancer is a disease in which some of the body cells grow uncontrollably and spread to other parts of the body. The growth of cells are so huge, which does not serve a purpose, and we are growing more and more. Cancer can start from almost anywhere in the human body, which is made up of trillions of cells. Normally, a human cell grows, multiplies through a process called cell division to form new cells as the body needs them. Now, when the cell grows old or become damaged, they die and new cells take their place. Sometimes this orderly process breaks up and abnormal damaged cells grow and multiply where they shouldn't. These cells may form tumors, which are lumps. Cancerous tumors spread or invade nearby tissues and can travel to distant places in the body and form new tumors. This is called metastasis. In short, I've told you what is cancer is an abnormal proliferation of cells. And the normal process that is to die does not happen. And it is instead of dying, some changes happen and which turns into malignancy. Now, what causes cancer? Cancer cell develops because of multiple changes in their genes. Multiple changes in their genes. These genes can have many possible causes. Number one, it can be lifestyle habits. Genes, you get it from your parents, and being exposed to cancer causing agents to the environment and can play a vital role. Now, lifestyle habits. You have a lifestyle habits where you smoke, and this smoke can cause a cancer. And other thing that is some people are exposed to some professional or the way they work, either in factories and etc., where they're exposed to some chemicals which can cause cancer. And many times there are no obvious cause. Now, when you go look at this cancer, there are biomarkers. This cancer leaves some biomarkers. Biomarkers are biological markers that indicate the presence of a disease or how well the body is responding to treatment. They can be found either in blood, tissue, or bodily fluids. Biomarkers are measurable and quantifiable biological markers such as proteins, DNA, RNA, and other biological components. Now, going further, what types of biomarkers are seen? You can have a pharmacodynamic biomarker, you can have a protein biomarker, you can have a prognostic biomarker, and a cardiac biomarker. The example for giving pharmacodynamic biomarker is it indicates how a drug affects the body, such as change in blood glucose level in a diabetic patient. Suppose a diabetic patient is on treatment. This will tell you how well the blood sugar is controlled. Protein biomarkers, it detects changes in proteins such as protein-protein interaction, immunological response, and post-translational modification. When you look at the prognostic, it predicts the likelihood of disease, progression, recurrence, or clinical events. So prognostic markers will predict the likelihood of disease progression, its recurrence, or clinical events. The cardiac biomarkers, which indicate the health of the heart, such as cardiac troponin, creatinine, kinase, and myoglobin. These are basic markers which really help when the patient has had a heart attack. And when these are raised, you know very well, this is a cause and you can treat it appropriately. Now, uses of biomarkers. In cancer treatment, biomarkers produce information about cancer, how to treat it, and each person's cancer has a unique pattern of biomarkers. Each person's cancer has unique pattern of biomarkers. Drug development biomarkers can indicate how drug affects the body, which can help the drug development. When you look at health monitoring biomarkers, it indicates a variety of health characteristics such as genetic susceptibility, exposure to environmental factors, and response to therapy. Going further, cancer biomarkers are crucial for accurate cancer diagnosis. They can be molecular, they can be anatomical, they can be physiological or biochemical. Biomarkers can serve as various roles, including in diagnosis, in risk, in diagnosis, that is identifying the presence of disease, risk assessment, predicting the likelihood of developing cancer, prognostic, forecasting the disease course and potential outcomes, predictive, determining the likelihood of response to a specific treatment, post-therapeutic, monitoring, tracking biomarker levels after treatment. The common cancer explains the common cancer explained are PSA, CA125, and CA. Now, when you look at PSA is a prostate specific antigen. This prostate specific antigen is generally normal in normal person. But if the patient is getting a prostatic cancer, this prostatic specific antigen rises. So it is one of the diagnostic marker in case of cancer prostate. After you treat the cancer prostate, now to follow it up, we keep the levels of prostatic specific antigen, PSA levels, every now and then so that either it should remain constant or increase. If it remains constant, that you know that disease in control. If it rises, you know that the disease is progressing. Now, so we need to take appropriate steps depending upon how the outcome is. Same way with CA125, CA, and other one is CA19.9, which is used for pancreatic cancer, both for diagnosis as well as for follow-up. Now, how to do a biomarker testing. Number one, you should carefully take the history, clinical finding, and take the lab results and follow established guidelines for testing and interpretation. The most important thing is to confirm the results with serial testing using the same method and the same lab. Don't go for some other things because sometimes it varies from one lab to another lab, from one way to the other way. So confirm, then monitor the biomarker levels after treatment. Account biomarkers, half-life, metabolism, and elimination. Use multiple biomarkers to increase the diagnostic accuracy. Carefully differentiate between biomarkers elevation due to cancer and other conditions. Now, we have talked about two things. Number one, we gave an introduction to it, to cancer. We talked about what cancer cell is. Now we talked about what are the biomarkers that are found in cancer. Now, the next thing that we are going to talk about is smart sensor. Smart sensors are advanced devices. Smart sensors are advanced devices integrated with technology that can sense, process, and transmit data. In the context of healthcare, these sensors play a vital role in monitoring cancer-related quality of life, offering real-time insight into patients' physical, emotional, and functional well-being. Now, what are the various smart sensor technologies? One is biosensor, nanosensor, the wearables like smartwatch, fitness band, skin patches, smart t-shirts, rings, smartphones, mobile health, and the other ones are implantable sensors, uh, environmental sensor, and biochemical sensors. Implantable sensor, they monitor the internal physiological parameters like tumor progression or medication effects, often used in advanced cases for continuous data. The environmental sensors like access to external factors like air quality, which influence patient's recovery as well-being. Now, just to give an example, if the patient is at in a home, you want to see what is the quality of air, how much of pollution is there, how much of uh, air you're getting a fresh one, and how much of oxygen concentration is there in that air. You need a sensor which can help us, and this would help in the outcome of the patient. Now, when you look at biochemical sensors, it detects biomarkability of body fluids, blood, saliva, sweat, useful in monitoring treatment effects and disease progression. Now, when we talk about biosensors, the biosensor's role is it revolutionary tool for early detection through biomarkers like mRNA, DNA, and protein. Now, the previous one, the biomarkers that we used were mostly based on what mRNA, DNA, and protein. The biosensors are devices detecting biomolecules with components. The biosensors offer a cost-effective, efficient, and sensitive alternate for detecting cancer biomarkers. The application include glucose sensing, disease monitoring, and cancer detection. Now, what are biosensors? What are biosensors? They utilize biological molecules to detect analytes, converting a biological response into an electrical signal, which are crucial for medical diagnosis. I read it again. I speak again. Utilize biological molecules to detect analytes, converting a biological response into an electrical signal, which is crucial for medical diagnosis. The analytical devices combining biological recognition elements with transducers. The components are bioreceptors, transducers. Okay. Now, coming to this, the best way to explain is number one. Now, you think this is the blood vessel. The analytes are there, and there can be antigen, DNA, RNA, or any other protein molecule. Now, these are recognized by these elements, that is biorecognition elements. Okay, this biorecognition elements later transfer into a biological signal which goes to the transducer, and it is converted there to electrical signal, and final the data is displayed. I hope you understand. On your left is your analytes, on your right is the element, and this element sends the biological signals which goes to the transducer, and this transducer converted into electrical signal, and finally it is displayed. And that's how we try getting this thing. Now, what type of biosensors are used in cancer? What types of biosensors are used in cancer? They are optical biosensors, electrochemical biosensors, thermal biosensors, nano biosensors, macrofluid distance, and quantum dose biosensors. Now, applications in cancer research. Now, the applications are biomarker detection. The early cancer detection, use of tumor markers like PSA, CA125, proteins, and DNA mutations, mRNAs for diagnostics. And the monitoring of treatment is assess effectiveness and detect recurring using biomarkers and liquid biopsies, non-invasive methods for isolating tumor cells from blood. What are biosensors in cancer diagnosis? Advantages of biosensors in cancer diagnosis. Number one, it's cost effective compared to the traditional methods. Number two, it enables real-time and non-invasive detection. It's highly sensitive and specific for cancer biomarkers. It is potential for personalized and precision medicine. Now, coming to the challenges that we face. The challenges are developing multiplexing capabilities for simultaneous detection. It is not one, if more or two or more early cancers are to be detected, you need multiplexing capabilities for simultaneous detection. Second thing is it reducing cost and enhancing portability. Complexity in manufacturing biocompatibility, limited biomarkers availability for certain cancers, signal interference and standardization issues. Future direction, integration of nanotechnology for higher sensitivity, commercialization of point-of-care devices, improved software for biomarker pattern, integration of AI for data analytics and personalized medicine, advancement in microreactors and 3D sphenoid models for drug testing, development of multiplexes devices for simultaneous biomarker uh, detection. Now, what is the conclusion? The conclusion is biomarkers hold immense potential to revolutionize cancer diagnostic. Number two, early detection through biosensors can improve survival rate significantly. Future advancement will make biosensors more practical and accessible. The impact is biosensing chips are transforming cancer diagnosis and treatment well, and further advancement would revolutionize personalized and precision medicine. Now we have talked about biosensor. The second thing that we will talk about nanosensors. Nanosensors. Nanotechnology sensors employ materials like gold nanoparticles, carbon nanotubules, which offer enhanced surface area and sensitivity for detecting substances. The role of nanosensors is it identifies biomarkers, circulating tumor cells, and extracellular vesicles for early diagnosis. Development of nanosensors. You people are better than me, but generally I speak about the steps in developing nanosensors are conceptualization and design of nanomaterial selection, sensing mechanism, whether it's optical, electric, or magnetic, fabrication technique, surface functionalization for specificity, and signal transduction and readout. Now, what type of nanosensors? Types of nanosensors are number one, it is nanoparticle based, carbon nanotubes, graphene based, high sensitivity, and metal organic framework. When you look at nanoparticle based, it's highly sensitive and selectivity, but very expensive. Carbon nanotubes or nanowires are robust, versatile, fast, but fragile. Graphene based, high sensitivity and low power, but issues with scalability and stability are there. Organic frameworks, high surface area, tunable properties, but slower response. Now, when you look at the application in cancer diagnosis, when you look at the application of in cancer diagnosis, in lung cancer, the biomarker is CEA, CYFRA, and NSC and mRNAs. The techniques that are used is graphene FTS, gold nanoparticles, which are used in the cancer diagnosis. In breast, biomarker is HER2, BRCA1 and 2, and ctDNA. The methods that are used is fluorescent nanoflobes and CMOS biosensor. In colorectal cancers, the biomarkers is CA, MSI, and ctDNA. The tool is DNA methylation markers, electrochemical sensors. Now, what are the advantages of nanosensors? The advantage of nanosensors are it's highly sensitive and specific, real-time monitoring, miniaturization for integration in wearable devices. It is small, it is easy, and it can be easily, done and dealt with. And the challenges of nanosensors are the manufacturing complexity and cost, stability and biocompatibility issues, signal to noise ratio interference. The future directions and goals, research goals are improve scalability, cost effectiveness, enhance stability and long-time use, develop multiplexed and point of care devices, and the impact is revolutionize early cancer diagnosis and personalized treatment. Nanosensors are transformative tools in early cancer diagnosis. The ongoing advancement will overcome current limitation, promising a potential for improving patient outcomes and globally. It has a very great, potential in future. The future direction and research goals are improve scalability and cost effectiveness, enhance stability, long-term use, and develop multiplexed point of care devices. Improves cancer diagnosis and personalized nanosensors are transformative tools in early cancer diagnosis. The ongoing advancement will overcome current limitation, promising potential for improving patient globally. The next thing that we are thinking about is smartphones. Smartphones. Monitoring cancer patients' quality of life is resource intensive. Can you understand if a patient is in a village, for him to travel, come to the city, and get himself evaluated with a doctor is going to cost him? Or they should employ a place where the doctor goes or the personal goes and a lot of money is invested. If people have this monitoring devices and quality of life, it can be very easily to get the data. The solution is utilize smartphone sensors for continuous and cost-effective quality monitoring. It is based on EORTC QLQC3 questionnaire. Now, EORTC stands for European Organization for Research and Treatment of Cancer. And they have made a questionnaire, and this questionnaire is made in the form of an app called Human Dynamic Reporting Services. Human Dynamic Reporting Services. This has the questionnaire of EORTC, and they have did a study on healthy volunteers and found that with the human dynamic reporting system, you design with a smartphone monitor and this thing. In that, They have monitored the track movement, location, phone calls, conversation, and data usage. And looking at that, the sensor that were used was accelerometer, microphone location services, and call details. The indicators include physical activity, social interaction, and sleep pattern, insomnia detection, and cognitive engagement. Sensor data was uploaded daily to a cloud database. The mapping of quality of life indicators according to this EORTC guidelines, the categories in terms of physical, emotional, social, and cognitive functions were, were given. And they found that it was feasible and confirmed for capturing relevant quality of data via smartphone sensors. Now, they found very well that it was feasible and confirmed that the quality of live data was very good and perfectly fine. But the challenges that you can face is battery and memory consumption, user compliance with tagging event, and the preliminary mapping between HDRS data and EORTC terms were successful. Usability assessment, system usability assessment scale said that the average score was 75, which means 75% of the people had a good score. And the problem of improvement is you have to improve the UI design, event tagging, and data synchronization. Coming next, the future direction says expand the pilot study to include cancer patient. This study was done on normal healthy patients, but this study has to be expand to pilot study to include cancer patients, enhance app functionality with automated activity recognition, integrate emotional and symptom tracking, adapt iOS, and refine usability for clinical trials. Now, the second thing is mobile health. The current data collection challenges are relies on electronic health records, patient reported outcomes, and clinical visits. The current data collection challenges are reliance on electronic health records, patient reported outcomes, and clinical visit. You need for automated system to replace this manual data correction. The mobile health technologies like wearable mobile devices like sensors improve data collection at trial outcomes. Opportunity of mobile health are real-time data collection, enhanced simple diversity, increases likelihood of trial success, and improving the data quality. The types of mobile health are patient-reported, task-based measures, active sensors, and passive sensors. Going further, next, challenges and limitations health, accuracy, provenance, and regulatory issues. In accuracy, the variability across devices, provenance, difficulty in tracking data lineage. The regulatory issues is lack of clear FDA guidelines for trials. FDA gives general guidelines, but there are lack of clear FDA guidelines for trials. Now, potential benefits are enables better patient engagement, shortens trial time, timeless, and lower cost, allows for integration with real world experience, data integration with telemedicine platforms for remote consultation. It helps us to get in touch with people all over the world with your data. The future vision is next steps are to integrate and establish FDA compliant protocols, implement robust security standards, address data accuracy and privacy concern, adoption of health could revolutionize cancer research by integrating wearable data, genomic advancement for precision medicine. Now, we talk about wearable sensors, electronic devices worn on the body. Significance is revolutionize in chronic disease monitoring and early diagnosis. The key advantage is portability, comfort, and real-time data. The devices that are used are acoustomechanic, thermal, electrochemical sensors. These measure the vital signs like heart rate, blood pressure, temperature, and activity levels. The applications are helps in monitoring hydration, detecting tyrosinase levels for melanoma, wound healing, and cardiovascular disease. Now, coming to smartwatch to monitor physical activity and heart rate during radiotherapy, but has challenges with adherence of 31% compliance, which means if the appliance is worn regularly, then you can have a good data. But if people don't use that same appliance every time, then you have a reduced this thing and because of non-compliance. Onco smart shirts, smart t-shirts, measuring biometric data like heart rate and respiration. The charges is low variability and significance and technical issue, which means it depends upon the material, it depends upon the comfort of the material, and at the same time, the person has to like it in order to wear it. Many times, I mean, he may find it difficult. Next, the technical complexities are charging devices and app connectivity issues, patient fatigue, that is, cancer patients have struggled with additional device management. If a cancer patient already he's having to go for treatment under radiation or something, and you add something to it, he may find it difficult. And third thing is material comfort and biocompatibility, which I've already said, battery life and portability, signal accuracy and stability, data security and private concern. Now, what are the future direction? The future direction is low adherence affected study outcomes. I mean, low adherence study outcome, which means many people could not adhere to the protocol that was given to them, wearing it regularly or etc. So people never got adjusted to it. Hence, the study outcomes were bad. Large data collection, potential exits, and framework of. I mean, if you have a framework, the large data that can be collected can be, can be optimized. And if you have a patient desire minimal effort solution that integrates seamlessly into their routines. Fully decentralized, bring your own device setups may reduce the barrier. Bring your own devices, which means whatever is supposed to be worn by that patient, if it is made and given to him, he can use it. But if you have one equipment, and that if you use it for everybody, probably it is not it is not possible. Now the recommendations is simply wearable technology for end users, integrate wearable data collection into existing healthcare system. Future research should address technical limitations, explore implantability, less intrusive wearable sensor, integration with AI and personalized IoT for personalized medicine, expansion into remote and home healthcare, collaboration between medical and engineering fields are more important. Collaboration between medical and engineering fields. I mean, this is more essential because I need something and you need to help me in getting something which is feasible, applicable, and sensible and gives me a reliable data. Further, the recommendation is And further, the wearables offer significant potential to improve in oncology care, but require user-friendly designs. Like if you're giving me a smartwatch or something, I should be in a position to wear it regularly. Or if you give me a shirt, I mean, the material should be compatible so that I can use it regularly. And it should be a minimal patient burden, like wearable sensors, bridge gaps in traditional healthcare, promising tools for early intervention and real time. The goal is shift towards personalized and remote healthcare solution. Now, what are the applications of cancer related quality of life? Number one, it's physical well-being. In physical well-being, you tracking of fatigue, pain levels, and physical activity, monitoring side effects of chemotherapy or radiation. Psychological health, like assessing stress, anxiety, and depression through heart rate variability and sleep patterns. Providing real-time feedback for interventions like medication and counseling. Now, treatment adherence, sensors in pills or patches ensure medication compliance. Suppose whether the patient is taking the pill well or not. If you have sensor in it, it will remotely tell the doctor this person either he has taken or not taken, looking at the data that he gets. Now, treatment adherence and sleep quality. Analyzing sleep quality disturbance common in cancer patients due to pain or psychological stress. You can know very well that this patient is not improving because he has a sleep disturbance or he's worried or he's depressed, you can get into him, rehabilitate him, support him, and you can monitor him and recovery during post-treatment exercises. So these are the conclusions that I make. Finally coming to the summary and conclusion, smart sensors are revolutionizing the way cancer-related quality of life is monitored and managed. Smart sensors are revolutionizing the way cancer-related quality of life is monitored and managed. For providing continuous real-time insight, they empower patients, healthcare provides to make an informed decisions, ultimately improving the journey and outcomes of cancer patient. However, addressing challenges like data security, accessibility, users' comfort will be the key to broader adoption. Now, the technological advancement is the major breakthrough in imaging technologies and molecular biology have greatly enhanced our ability to detect cancer at earlier, more treatable stages. The importance of continued research efforts are essential to further improve the diagnostic method and to stay ahead of evolving cancer cell behavior. Thank you for your patient hearing. At this point of time, I cannot but mention my three junior doctor colleagues who helped me to go through all this, understand, and I really appreciate and thank my three doctors, Dr. Sandhya, Dr. Rasool, and Dr. Tushar, who made this far. Thank you very much for your patient hearing.
Participant, you have any queries, please ask. I think so. No comments, sir. No questions. So thank you, sir.
Sir,
Thank you for agreeing my. Yeah, sir. Please.
yes, sir. Related to cancer issues, in real-time scenarios, can you show me any related, analysis of the sensor mechanism, sir?
Sir, we are working at it. The various sensor mechanism that we just not in it, not. I mean, I work in a government hospital. I have not done so much of it, but when you look at the way my uh, my machines are made, they are all based on sensor mechanism. The way when you look at if you're having a lung cancer and you know very well that this cancer is in this way, and the normal way that I treat is one anterior and posterior, but when you look at the way the person is breathing, you know it is it's moving in different direction, and it's a three mode direction. It can be x, y, and z. In such a situation, you expect your sensor. We take the help of sensor to look for the movability or the mobility of uh, that particular tumor tissue, and we form a pattern, and once we form a pattern, we get out to step and shoot, and that's how we try and get it. Instead of trying to give in a normal way, sometimes I may miss the tumor, but the sensor helps me to detect the mobility and help me to shoot.
So I think tumors related, sir. In the sense of brain tumor related cancers parameters. So these realistic analysis we need to analyze with the help of sensor mechanisms.
Sir, now when you look at this thing, like we need to some of the things that we look is, suppose we want to take a liquid biopsy. Now there are tumor cells which are flowing in the blood. Now you cannot take a biopsy from a very internal or inside the place, because people don't want it or something like that, it's very feasible. This pan is old and you are worried about the complication. Instead of that, we try and take the blood sample and take it and look for these antigens based on this mechanism. We try and identify what type of cancer could it be. That is called a liquid biopsy. And this one helps to a certain extent, but is very expensive and it is not feasible now. But this is a possibility. This is very well done.
Okay, sir. Thank you so much, sir, for a wonderful
Thank you very
session.
much. Sorry if I have not answered you so well, but I'll try and
No,
help you
no,
out.
sir. Don't,
But
sir. You have the given lot of information related to, I mean, realistic sensor mechanisms in the healthcare systems.
yeah,
We feel
thank you
very
very much.
happy about your session, sir.
Thank you very
Thank
much.
you so
Thanks for
much.
your patient hearing. Thank you very much.
Thank you, sir.
Thank you very much, sir.
So participants, do you have any queries? So I think no queries, no, sir. So thank you very
Thank
much,
you very much,
Joseph,
sir.
sir, for agreeing. So my request and I accept and given a good lecture to the participants, sir. Thank you very
Thank you
much,
very
sir.
much, sir. Thank you very much. Thanks for the privilege.
Thank you, sir. If participant next session will start in so half an hour. So a lot of requests are coming. So actually we are planned to schedule for the 4:30, but lot of faculties are moving in the buses. That's why we are planned for the 5 o'clock. Half an hour break. We are this 45 minutes break we are taking now. From 5 to 6:30, one more session is there. So after that, we'll go for the test. I will share the link in our WhatsApp group. So 30 multiple choice questions are there. So for that, you have to write the so give the options immediately. So the answers also will get and the score you have to get. So as per the ACT norms, you have to achieve so 80% of marks to get the certificate. So 30 bits we are giving 1 hour time. So please answer for the questions very properly. And the feedback link already activated in your Atal portal. And one more thing, we don't have any control to on and off. So the total control is taken by the Atal IT support team. If not open, please put a mail to them, IT team for in the Atal. So for that mail, you can go for our main Atal portal.